Hello, and welcome to Answer Everywhere. Every day we take a look at not every day. Every episode, we take a look at some software we haven't seen before and poke around. We've been learning a little bit about FPGAs, chips, Verilog, that sort of thing. I don't have any of that in my background, so I'm just exploring. This is not, for example, a channel where you would learn from a master of hardware. I consider myself to be pretty incompetent at all that stuff, and I'm just kind of learning a little bit as I go. But I thought it would be fun to jump up a layer or two or several of abstraction and look at one of the video drivers. So instead of looking at how the GPU is implemented at the hardware level, to look at what the software that interfaces between the operating system, in this case Linux, and the hardware, in this case a GPU. And I chose the Nouveau driver primarily because the only thing I really know about it is that I always blacklist it if I have an NVIDIA card. I don't really know what's up with that. My understanding is that NVIDIA only has like closed source binary blobs for video drivers for Linux. And so the Nouveau is the kind of like fully open source alternative. And because they basically have to, if I understand correctly, reverse engineer NVIDIA's cards because they're not documented and there's no open source drivers for them. These drivers end up not being able to fully appreciate all of the beauty of the NVIDIA cards and can lead to hardware problems, some of which are subtle. So I thought that would be an interesting place to start, because we should see maybe some of that struggle in the code, and that might tell us a little bit about what it's like to think about GPUs from an operating system perspective, where you don't have like full godlike omnipotence knowledge into how the hardware works. And that might be instructive. It might not be instructive. I'm not sure, but we'll certainly find out. Okay, so I also open up the Wikipedia page, and it is telling me it's for the Tegra family of system on chips. That might be old. I'll take a look at that article briefly. The project's goal is to create an open source driver by reverse engineering NVIDIA's proprietary Linux drivers. Okay, so this is maybe, at least Wikipedia is claiming it works a little bit differently than I thought. I thought that they were working from the hardware to kind of reverse engineer the hardware. It seems like they are maybe working from the proprietary drivers to reverse engineer it from the software level. I'm not sure that's totally cool. Maybe this is just misdescribing what's going on, but maybe we'll see a little bit about that. And it's distributed as part of Mesa 3D. And it was previously 2D only, etc., etc. Okay, I have not read this Wikipedia article, but I will. Here is some graph in the middle. The FOSS stack composed out of DRM and KMS driver, libDRM, and Mesa 3D, right side proprietary drivers, kernel blob, and user space components. I think I've looked up these before because we've come across these when looking at other repositories. I don't really remember the difference. Direct something management, possibly. Kernel something driver. We'll look up those. And Mesa 3D is one of these libraries for graphics that I always understood to be somewhere in the stack and don't really know what it's doing. But let's see if we can understand this a little bit. This is input somehow. This is USB input and output. This is some display controller. This black line is CPU and main memory. This blue line down here is GPU and graphic memory. I'm guessing this is supposed to be the hardware. And the USB component talks to EVDev, which I'm something device. And then the display controller, which I'm guessing is part of the hardware. Modern solutions. I'm seeing semiconductors. I'll add this to Wallabag as well so I can read it later. Video display controller. is an integrated circuit. Okay, so the display controller is a circuit, is a piece of physical chip. It talks to KMS, which maybe stands for. Did we open this? Oh, it's under the direct rendering rubric, kernel mode setting. And I remember mode setting is something that I often have to disable on laptops as well. So it talks to the kernel mode setting thing and also to DRM, which is what? Direct Rendering Manager. Responsible for interfacing with GPUs of modern video cards. It exposes an API that user space programs can use to send commands and data to the GPU and perform operations such as configuring mode setting. Okay, so I don't know what mode setting is. This sounds like the DRM is basically a go-between between the GPU and the software world, the kernel. It's kind of like maybe the main proxy that exposes an API that's universal for video cards. And mode setting, it seems like maybe it's like mode-based, like VI, like the editor. That activates display mode, screen resolution, color depth, and refresh rate. So I guess a mode we're going to think of essentially as a triple of data for configuring things like resolution, color depth, and refresh rate for the computer's display controller by using VESA BIOS extensions or UEFI graphics extensions. Okay, and I will read all of these. And you might think, shouldn't you have read all these before looking at this repo? Well, maybe not. That's part of the fun of exploring software. Okay, and then over here, for some reason, we have a proprietary blob, which also talks to DRM. And this is like libgl, NVIDIA GLX, libgl, AMD GPU Pro GLX. But if you don't have the proprietary blob, then you can use the free and open source drivers, which somehow will use Mesa 3D. So maybe this is like another layer in between. So Mesa is an open source implementation of OpenGL, Vulkan, and other graphics API specifications. So I'm going to think of this as essentially Mesa 3D is an open source repo that has implements some common APIs. And I believe OpenGL and Vulkan are both, what's the word, like public standards. Cross-language, cross-platform application programming interface. I mean, I think it's a standard and not software. Not entirely sure. Oh, I will also add this to Wallabag. I think I've looked at these before. I don't really remember them. I'll ask one of these. It says DeepSeek. What? I think I'm logged in. Are OpenGL and Vulkan pieces of software, or are they graphics standards? The same way something like TCP is a standard. DeepSeek is very slow. I assume it's because the bits have to go all the way to China, across the Great Sea. So the graphics APIs, they can be thought of as standards. So I guess they just define the API like on paper. Okay, whatever. All right, so that's just helping orient me a little bit. I don't have a ton of time. There's probably better uses of my time, like jumping straight into the code, but I think that this is going to actually make it easier to understand what I'm seeing. And then we have the Wayland compositor. So this is if you use Wayland. And this includes a bunch of stuff like Weston, Mutter, Kwin. Okay, so Kwin is the compositor, I think, for KDE. Mutter, I think, was or is the compositor for GNOME. And I think that these have been since Xorg as well. No, Mutter is specifically a Wayland display server and an X. Okay, yeah. But was that GNOME? Where did that go? Yeah. All right, so that's how I'll think of it. And with the Wayland window management, and it has inside somehow an X window manager And then we have X Wayland, and this is maybe just some, X11 talks to X Wayland, et cetera. But where's Nouveau? Here's lib input. There's a 3D game engine that speaks Vulkan, OpenGL, et cetera, and that either talks to Mesa or to the proprietary driver. And that's basically it. And the proprietary blob bypasses DRM and KMS, it looks like. And so that's actually useful to know. I would have thought, all things equal, that these would be at the same level of abstraction. Although DRM seems to talk to, never mind, take that back. There's a line here, although we bypass libdrm. So these kind of are at the same level of abstraction. Okay, fine, whatever. That will be enough for me. So here are the files. This is GitLab. I'm on the master branch. I also downloaded the code. I'll generate tags for it in the background. The other branch, the branch it defaults to, if you just click on the Nouveau link, is something like DRM next, and it doesn't have commits that are as recent. And we have crypto inserts. That's a little bit unexpected. I don't know what it's doing with those things. It says something about PKCS11. Am I on the wrong Nouveau? We also have possibly a file system and drivers and some includes. And an IOU ring, IPC kernel lib. We'll open all of these. They seem to be experimenting with Rust. I don't know what MM is. Let me verify this is the right thing. There are several guides for kernel developers and users. So if I go to the Nouveau driver page, it tells me to go here, which is where I was. Okay, so I believe I'm in the right place. My main question now is, why do you need certificates? What are they for? And inserts, we have blacklist.c, blacklist.h, and revocation certificates. And extract cert.c. So PKCS11 is an older cryptography standard, not that old, but it's still very huge in industry. 1994-ish. So why do GPUs need PKCS11? Or do they? NVIDIA has a thing about it. Is this maybe to make sure that you're, they have like a trusted display? So it's available to drive OS applications running on the guest OS that provides a subset of PKCS11 interface. Huh. But why? Slots and tokens. It represents a combination of persistent object storage and access to cryptographic hardware. All right, let's ask Gemini. So why do GPU drivers need to know PKCS11 support? Stems from the increasing importance of hardware-accelerated cryptographic operations and secure key management. The GPU's role in cryptography. GPUs are increasingly used for cryptographic tasks due to their parallel processing capabilities. Oh. So it also enables GPU drivers to interface with secure hardware, allowing cryptographic keys to be stored and managed within the GPU's secure enclave. or a connected HSM. And for automotive, there's a need for secure communications and secure data processing. So I guess they're not used for display. So is it used for display at all, or only for non-graphic GPU computations? Okay, so it doesn't seem to be anything necessarily about like secure display. Like you could imagine a world where you were worried that, I don't know, you work for the NSA and you want to make sure that the JFK assassination documents are not like fake by somebody like hijacking your GPU or something along those lines. But it seems to be for other purposes. Okay, in which case we will kind of ignore those for now, as much as I love crypto. In file systems, or rather in FS, we have a bunch of stuff, including HFS Plus and HFS. Those are Mac file systems, huge TLBFS. I don't know what that is. LockD, Minix, NFS support, Notify. I'm not really sure what we're doing with these file systems. Should we look at, let's look at NFS, I guess, and just see like what sort of thing they're doing. We have information about the block layout, file layout, some cache, callback, etc. Again, I don't know really what they are doing with this. This again may be for computation. And then in Nouveau, we have drivers, which includes Android, aux display, base, Bluetooth. This is way more in depth than I thought it would be. I'm not really sure what I was expecting. For example, it's not clear to me why you would want all of this stuff to have a different implementation for each GPU platform. So let's continue to poke around. I'm doing another stream tomorrow. I think I'm just going to come back to Nouveau. I'll spend today kind of trying to come to terms with what it is, like what is even the scope of this, and then we'll pick where we want to dig in. We do have a Linux directory under what? Under Nouveau include. So maybe this is just includes possibly from the other Linux sources. And we have IO uring. Uring, I don't know what the U is for. Maybe uring is a thing. Uring. Uring refers to IO. Uring, a Linux kernel system call interface for asynchronous IO operations. Okay. Let's go back to Gemini and say, why does the Linux Nouveau driver also need file system implementations? Or, yeah, file system code, e.g. for NFS and FAT. So it doesn't directly implement the file systems. However, it interacts with the Linux kernel subsystems, which do handle those files. Modern GPUs, including those targeted by the Nouveau driver, often require firmware to operate correctly. The firmware might be stored in files. Okay, so maybe it's just for loading firmware, and the driver needs to be able to access these files. I don't know why you couldn't just have another part of the system load the firmware from disk and pass it as a piece of whatchamacallit, but maybe the firmware is too much to treat it as just like a binary thing, and it needs to be like, it might have to make choices based on the directory or subdirectories or whatever. When Nouveau driver needs to access a file, it makes a request to the kernel's file system layer and then a bunch of stuff, blah, blah, blah. Okay. So I guess I'll believe that. It's for the GPU reaching out into the file system to get files it needs. And then IPC should be just interprocess communication, which seems reasonable. This is kernel. I'm guessing this is mainly like all of the kernel related stuff that it needs to talk to other things. Again, I don't know why these are like, why can't these be shared, or are they shared? And these are essentially just copied from other drivers as well. I don't know. And what is this? This is lib. And we have a bunch of stuff, including crypto, fonts, KUnit, Reed Solomon. I'm guessing a bunch of this is somehow shared, although it may not be apparent through it being in a separate repository. I don't know. And I'm not going to find out. Net, Apple Talk. But like, does like Nouveau actually support net? Like, is the GPU speaking on Apple Talk? It doesn't have its own. It doesn't have its own like internet connection. It seems like it would go through the CPU. I'll look up, why does the Nouveau driver need Apple Talk support? I don't know. It might directly interact. I mean, it's possible that I think, no, I don't believe that. Network GPU appliance. It's possible for some sort of like, it's for something like that, but I'm not convinced. Here's some Rust stuff, I think. Is that where we are? We have bindings, kernel, bind gen parameters, and FFI, which I'm guessing is the foreign function interface. Then we have a samples, including fprobe, fan notify, daemon, high draw. Is that high resolution? High draw. Raw access to USB and Bluetooth human interface devices. Okay. KMemLeak, Rust, seccomp, VSS, WatchQ, Watchdog. And then we have include Linux, including Ceph. I'm really unclear why it would need to know about Ceph, which is a network-based, a network distributed file system thingy. Okay, so there's a ton here. The thing that I think that I really came for is the firmware. So let's see if there's something firmware-ish. And there is. And let's take firmware and let's make it its own window. Okay. And we have some chip stuff. We have Broadcom, Cirrus, EFI, Google, IMX, Meson, Microchip. I don't know what Microchip is. I don't think it's like a chip company, is it? PSCI, QCOM, and then some XE Linux, which is some FPGA stuff that we've run into before, and some DMI stuff. And some iSCSI stuff. Memory map, Raspberry Pi. Why does Nouveau need to know about Raspberry Pi? Trusted foundations. That may be some trusted computer thing. You have QEMU emulation. Whatever EDC is. DMI scan. I'll just open a bunch of these. I don't know what kconfig is. It might be useful to look at some of the configuration stuff. I don't think I rarely learn anything by looking at a make file. But I guess I'll open up a bunch of these. Google is possibly interesting. EFI, I'm going to guess, is not interesting, but maybe Broadcom. ARM Skimmy and ARM FFA. I don't know what SCMI is. Super microcomputer? System control and management interface. Okay, and then what's ARM FFA? Firmware framework for a profile. Okay. Microchip just has this thing, MPFS auto update. We've got this SPDX license thing. Something about polar fire FPGA. So this is just copied. This is copied from some other thing. I don't know where or why. And this is some stuff about SPI flash layout. So we're going to ignore that, I guess. Here's the C Linux thing. And again, this is going to be what? Something. We've got CRL registers in Bitfield, et cetera, et cetera. Structure for the Zin QMP device instance. Okay, so this is for interfacing, I guess, with a particular device, C Linux device. I don't know how to decide which of these devices are worth looking at. I think Tegra was what Wikipedia told me that this project was really about. But obviously it's like spawned and into many directions, like an octopus. This is what? This is DMI ID. I don't know what that is. We have things like DMI device attribute. DMI device attribute again. Stuff about showing DMI fields. We're going to define a bunch of attributes with the DMI BIOS vendor. I don't know if this means that like the field is 0444 or if that's the vendor. And these are like, I guess, human readable codes for things like SKU and which vendor are we. I'm guessing maybe this is from the kernel or something, edd.c. What if I just do a search for edd.c as a file and see what comes up? The California government. All right, let's try another tack. Let's grab some bit of code and Google that. File not found. Let's try it this way. Yeah, okay. So this is from Linux drivers firmware. And I'm guessing we're just essentially vendoring the some firmware drivers. Is all of this from Linux? Yeah. So what actually is Nouveau? Is Nouveau anything? Or is this all just from the Linux kernel? We have include UAPI, DRM, Nouveau, etc. So let's take something that was confusing to me and see if we can find the Linux corresponding thing. In fact, let's just go to Linux and look at its directory structure. This looks the same. So I think that what I'm looking at here, this Nouveau, is just the Linux tree. Is that possible? This is essentially a fork of Linux. Okay, and this explains why it's much more sprawling than I thought it would be. Okay, so this is essentially a fork of Linux. How big is this? 2.4 gigs. So what actually is Nouveau in this repo, and why is it here? And what is DRM? This is the kernel graphics development. Are these all forks of Linux? Yeah, possibly. Okay, so I guess what we want to do is we want to figure out, assuming this is just basically a fork of Linux, we want to figure out where the history diverges, I guess, from, or unless master is specifically the mainline kernel, and DRM next is just the changes for Nouveau. I don't know. So this is merging tag DRM next, merge MediaTek DRM next, blah, 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 DRM/XE. Yeah, I'm guessing that's what's going on. So maybe I don't want to be in master. Maybe I want to be in this one. And let's compare this to the master history. I did notice that Linus Torvalds is the one doing a bunch of merging. So let's take a look at this and see if this has any DRM or Nouveau specific stuff. Hardware mon fixes, branches, blah, 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 2 change files, maintainers, and this thing, which doesn't seem to be particularly Nouveau-ish. And let's pick up another one kind of at random. hotfixes. squashfs and procfs. Okay, so I think that let's just start over again. And let's go to DRM next. And maybe the only way we can understand this is by looking at the history, or at least looking at files that are frequently changed by the history. So what is this? Where? What file are we changing? Firmware EFI mulkvar table. I don't know. I don't know what a mulkvar table is. So I'm going to start a new chat with Gemini and just ask it, where is the code for the Linux Nouveau driver? So I think that what I'm looking at is the Git repo for the Nouveau developers, which is different from just the Nouveau repo, because I think that they're working on essentially, this term gets way abused, but you could kind of consider it something like a mono repo, the Linux kernel repo, and they just have sort of a different view of it. They're emphasizing some things more than others, and I was confused. I thought I was looking at a driver specific, a repo specifically for Nouveau, and so the question now is, can we figure out what is different about their view, or at least where can we find the code that's relevant to Nouveau? Okay, so Gemini says the Linux Nouveau's driver code is spread across a few key locations, reflecting its structure as a multi-component driver. It's in drivers DRM Nouveau. Specifically, the key file is Nouveau drm.c. And Gemini is just telling me to go to the Linux repo, which is probably a good idea. The 3D acceleration part of Nouveau is implemented in the Mesa 3D graphics library using the Gallium architecture. And then libdrm. So these are so which parts of these are specific to Nouveau rather than shared by other Linux GPU drivers. Yeah, I understand they share common infrastructure. A significant portion of Nouveau's development has involved reverse engineering NVIDIA's hardware. As blah, blah, blah. We talked about that. Tools like Renouveau. Okay. The NVKM NVIDIA kernel manager. GPU system processor the way... Okay, so... Is Renouveau really a thing? Let's see if we can find that. How about Linux? So this does seem to be a thing. And this is migration status. Help Nouveau reverse engineer. Okay. Can I find code? Oof. So where is it migrating to? Oh, the new server. Where? Kubectl. How about something with HTTPS? You've got some S3 thing. How about a GitLab URL? Okay, Equinix. So they're using Equinix, they're using Kubernetes. That's all fun. That's all good. I don't know where Renouveau is. How about Renouveau GitHub? There's a Renouveau OS. How about Renouveau reverse engineer? Is this the migration thing again? All right, you know what we're going to do? How do you do archive.org? I'm just going to grab this and plop it in archive.org. web/star, I guess is the way to do it. So let's look in 2024. Renouveau has been superseded by Valgrind MMT. This page is here for historical reasons. Okay, so this was a reverse engineering tool, and now instead of using this, you're going to use Valgrind. I will read this page, even though it's here for historical reasons. I'm guessing Valgrind MMT is a Valgrind sub-product or sub-tool, and it may not be, probably is not specific to NVIDIA. It allows tracing application accesses to M-mapped memory, which is user space parts of graphics drivers, which is how user space parts of graphics drivers communicate with hardware. Okay, so you're just passing this tool MMT. We should look at the Valgrind stuff eventually. I don't know if Valgrind is obsoleted by LLVM, which we have looked at. Memory address sanitizer versus Valgrind. Is address sanitizer better than Valgrind? It seems like they are in the same space at least. Okay, so with all of that, let's find some information about Nouveau specifically, and then we'll have like 2 seconds to look at it before I have to go. And then I guess tomorrow I'll come back with a newfound appreciation for where the Nouveau stuff actually is. It says drivers, GPU, DRM, Nouveau. Do we believe it? I think I believe it. although I went to their commits and not to the folder. And so how do I go to the folder? Let's maybe try this again. I don't know what the, yeah, I've got to have this tree, Nouveau next, etc. Block, question mark thing. Oh, block is the name of the folder I went to. Okay, this is a real folder. And this is looking much more like I would expect a driver to look like. So I'm just going to leave this up. Maybe I will go ahead and open a bunch of files here and make sure that the other windows are closed so that I don't have to get confused about them. Okay, I don't know what these folders are. NVKM, NVIDIA kernel something, management, NVIDIA IF. I don't know, DISP, NVIDIA 50 and 04. Those may be versions of, those may be versions, I don't know. We have NVIDIA ABI, that should be the application binary interface, a CPI, which is something about power. I misspelled Linux. Power management technology. We have Nouveau BIOS. I don't know if that's important. Backlight is maybe important. I don't think I ever opened a CPI. We'll open that. Whatever bow is. You might just open all of these. These with the numbers, I'm going to guess are like specific like version implementations. I'll open a few of them. Some might be way more interesting than others, but we'll probably only look at one and really only very quickly. Nouveau Chan, maybe channel, some connector stuff, CRTC. I thought for a second about CRCs, which is not what it is. Okay, and then Nouveau display might be an important entry point. That's probably should be a bit more at the beginning. DMA, maybe direct memory access, although I don't know what DMEM would be in that case. DRM. Is that the thing that we just looked at, display something manager? Direct rendering manager. Okay, yeah, so we'll look at all of these. I don't know what DRV is. Some encoder, exec, fence, hardware mon. Do we care about hardware mon? Maybe not. We'll open the header for it. And mem header, memc. Yeah, okay, so there's enough here to at least spend an hour on it. Prime. I'm hoping that's prime numbers. Maybe some scheduling stuff. I don't really know. We have enough for a full hour, so I don't want to overload us, but I'll open just a few, basically everything. And should I open a bunch of these fences? I guess, why not? We've already gone wild. Okay. I should probably stop there, but I think I'm going to at least take a quick look at some of this stuff. Maybe one of these fences, because that's where we are. We don't see a lot. I don't know what a fence is. We can create and destroy fences. We can read fences. I think maybe a fence is like a barrier. Electric fence. Let's try hardware GPU. Native GPU fence. The GPU fence synchronization object that can be used for true GPU to GPU synchronization. Okay, so in GPU code, what is a fence? A fence is a synchronization mechanism used to manage the execution order of commands between the CPU and GPU or between different GPU queues. Here's a breakdown. So GPUs execute commands asynchronously, meaning the CPU can submit commands, etc., and it waits to get them back. Fences provide a way to ensure that certain GPU operations have completed before the CPU or GPU tasks proceed. Signaling. A fence is essentially a signal that the GPU sets when it reaches a specific point in its command stream. When the GPU completes the commands preceding the fence, it signals the fence. So that's kind of different, I think, from a mutex or something. The CPU can wait for the fence, etc., etc. So I'll say, is this different? Is it more different or more similar to something like a mutex? So they're both synchronization mechanisms, both serve different purposes. They're used for coordinating, blah, blah. So fences just do signaling and waiting. Mutexes do locking and unlocking. Yeah, okay. So it really seems like it is just like a signal. Like I'm done or I'm at this part. And we have like fence emit. We're going to create this struct nvif push. The F might be fence. Fence channel chan.push is going to be this struct. We're going to grab it from the channel, which we get from fence. We're passing in star fence, a pointer to fence. And then we're going to call push wait. And whatever 2 is, probably not 2 seconds. I assume 2 units of time. Maybe nanoseconds or something. And we're going to get some return value. If return is 0, then we're going to call push nvsq, passing in push, which came from where? I don't know. And nvsw, which also, I don't know where it came from. And whatever this thing is, some magical number. And I guess we have a sequence number from the fence that is maybe telling us like, so we like increase monotonically and don't go back in time or something. Like the TCP has a sequence number. And then we're calling push kick on push. And then we're going to return the return value we got when calling push wait. So these push things seem important. Let's see if we can find, I don't think GitLab, oh, we do, has a search is what I was going to say. Let's look up push wait. I don't know how good it is. So these are calls to push wait. I think I have tags now. DRM, Nouveau. So let's just see. Whoa. Let's see if tags will help us here. Oops. Okay, yep. Although, where are we? This is an NVIF. So push wait is a static inline thing. It's going to take a size. So push this thing that I thought was a time that we were waiting. It is not a time. It is a size. Here, this push wait 2. And what does it do? If push current, which is maybe a pointer to the current thing we pushed or something along those lines, plus the size is bigger than or equal to the push end. So if we have if we don't have enough space, wait, what? I guess if we do have enough space, I don't know why we want it to be larger than the end. Maybe that means that we're not clobbering something. But then we're going to call, if that happens, we're going to call push weight, accessing weight with this right arrow thing, passing in the push that we called it on. Seems like we maybe already have a reference to that in the size. So this is the real call. This is just the call that wraps it in some sort of checking code, namely this check. And if we get the return, we're going to return. And this was formatted like a complete madman who I guess did not like braces, but did like extra white space. Just out of curiosity, I'm wondering if this is a tab or a space. Seems to be a tab. Okay. And then if we've got this config nouveau debug push, this is some debug behavior, then we might set push seg to push cur plus size, I guess, for debug purposes. And then we're going to return 0. And we only return 0 if this check fails, or if return, well, if return is 0, this will fail. And then we'll return 0 down here. And if return is non-zero, this will succeed. So it kind of seems like we don't have to do this check. Although if we didn't do this check, we would bypass this debug thing. Okay, so that's what push is doing. And NVIF push is this struct here. And we have, what's going on here? This is like a, I guess like a pointer to a function called wait that takes in a struct called NVIF push, which is the same struct we're in. So this is like a recursive thing. And it takes a pointer to push in the size, and void, and it returns whatever it returns. It returns the success code essentially, I think. And then a function kick, which takes a NVIF push thing and I guess probably deletes it from whatever struct it is, presumably something listy. And then we've got internally an NVIF memory thing. And a bunch of U32s, beginning, current, seg, and end. Seg is, we know, is used for debug here. I don't know what else it's used for, but this is like pointing to the various parts of the structure, which I assume is listy. And we can open up another window pane here. And do I have God mode? Yeah, okay. And then we can go to the, no, we can't, because we are in include. So let's see if we can find let's see if we can find the corresponding C file by doing tags. What is find references? Okay, so these are, let's see, what do we want? Push.c? We have push.h. NVIF push is really what I want. Oh, no, okay. Wait is what I want. These are different implementations of wait. I don't know. What? That's not what I did. Oh, it's because I'm in God mode. Let's try this one more time. Yeah, unless I'm missing something, what is the actual implementation of this wait? Am I staring at its implementation and not seeing it? We're including drf, we're including print and mem. Here's a bunch of more pushes. These are macros with some asserts. And it seems like we're adding to the pointer directly. Push kick is going to call push kick on push. Start a new chat here. So what's the actual implementation on push here on the struct and VIF push? So Gemini is saying that the NVIF push struct and its associated macros provide an abstraction layer for building command streams, push buffers for NVIDIA GPUs. Here's a breakdown. So the function is a function pointer that's called when the push buffer is running out of space. It's responsible for making space available. I don't know what a push buffer is. Zerka Bill is asking, do I use Emacs without conf? No. 1 second. The Emacs here is under configured in the sense that this is a VM. Whoops. Hey now. This is a VM that I use just for streaming, and I think that I've actually done all of my Emacs configuration on screen in one thing or another, but it's not configured like my home Emacs. So I just generally get pretty confused about what is enabled and what's not. Okay, so wait is a function pointer that's called when the push buffer is running out of space. It's responsible for making space available. Kick is called to submit the built command stream to the GPU. Okay, so I thought kick was removing stuff, but I guess it's like I guess it's sending stuff to the GPU. So mem, likely representing memory region, etc. Beginning, current, segment, end. We saw this. That's for debugging. The macro checks if there's enough space in the push buffer for the requested size. If not, it calls push wait function to allocate more space, and then push kick, etc., etc. So I'll say, but where? So you say it calls push wait to allocate space, but where is this defined? So wait can hold the memory just any function that matches the signature, and it takes an NVIF push and returns int. The actual function that wait points to is not defined, within the nvif push.h header is defined elsewhere in the code that uses nvif push structure. Okay, so maybe it's in this fence. Like, I don't know if each fence thing. Oh, yeah. Well, hang on. Yeah. That's kind of where we started. So we're looking in the fence channel on the chan.push. And I guess that's the function. No, that's the nvif push thing. So wherever this is populated. Do we have a push equals anywhere? No. Okay, so we'll find out more about this tomorrow. I do have to go. Yeah, so we'll look more at Nouveau tomorrow morning, 8:15 a.m. Eastern Time.